So today, especially in the second part of the event, we could see how the refueling of the hydrogen trains and the interface between the hydrogen refueling station and the hydrogen train is still a big issue for those who are working in this topic, especially the communication. And since there are no refueling protocols, so everybody is just doing the refueling in the way that they can without any standard behind it. And this shows that what we researched in the HyTrain project is of high value for us and also for the industry. So now we can make use of this hydrogen refueling protocol which is available and which can be of use for all the other industrial partners. Thank you very much, Nikolaus, for this introduction. So, I work at FEN Systems, representing the Green Energy Center Europe in Innsbruck. You already heard the introduction from its founder, Ernst Fleischhacker. Since 2014, we have been supporting FEN Systems clients regarding the reconstruction of their energy system towards climate neutrality and energy autonomy in 3 fields of strategy, project and product development, quality assurance and monitoring, dissemination and training. In addition, since early 2019, all research activities are bundled in FEN Research, which is an independent, non-profit research organization focusing on inter- and multidisciplinary systems and logistics research. So FEN Research operates 2 research laboratories, eWest and HyWest, focusing on power on demand and power to hydrogen processes and also the interaction between these processes. Now today in my presentation, I will give you an overview regarding the research and development WIVA P&G HyTrain project. First, by introducing the project consortium, project objectives, secondly, by presenting results, and lastly, by giving you an outlook on synergies with projects and programs for the establishment of the green hydrogen economy in Tyrol and in Central Europe in general. So the proposal for this project was submitted in 2018, and after evaluation and acceptance, received funding from the Climate and Energy Fund, and it started its activities in 2020. This is a flagship project regularly evaluated by independent international expert panel. So the total project budget is around 3 million euros, and currently is at the latest stages of completion. Regarding the consortium, as mentioned, the consortium lead is FEN Sustain Systems, who, as developers of the commercial Zireh Taliban 2020 plus energy autonomous for hydrogen, initiated this research and development project to tackle the higher risks regarding the implementation of a hydrogen train. So the project operator with rail operation competence is Zireh Taliban, PROSE with train and railroad competence, HyCenta with hydrogen competence, and WIVA P&G as network coordination is representing the corresponding energy model region. As I mentioned, FEN Systems initiated this project to build up know-how for quality assurance and risk minimization for the implementation of a hydrogen train. So the first objective was to establish the state-of-the-art for hydrogen trains, and that by means of train simulation and test bench operations, and also to develop a holistic hydrogen infrastructure concept. The second objective was to determine criteria and parameters for hydrogen trains and corresponding hydrogen infrastructure for the quality assurance and risk minimization process. And that was regarding tendering, contracting, commissioning, acceptance, operation, and warranty. And the last objective of applying all the findings of this research and development project to the implementation project, which is now foreseen in a follow-up project. So now with the objectives classified, the project developed two research teams, one focusing on hydrogen train and one focusing on hydrogen infrastructure. For example, for the hydrogen train, one of the main research topics are the lifetime of the train and also the optimization of the energy consumption, since these two parameters has important impact on the operational costs, but also degradation of the fuel cell system health monitoring using real-time recognition state, and also improvement of the operation strategy and optimizations for lifetime efficiency and performance. Regarding the hydrogen infrastructure, so the main focus was the interface between the hydrogen train and the hydrogen refueling station. And for that, a refueling protocol was developed in terms of cost efficiency and time of refueling. So now I would like to give you a broader outlook regarding what has been done. So for example, when it comes to degradation and health monitoring, no device other than cell voltage monitoring is available, where each cell is wired, so the measurement is prone to error. And in HyTrain, we came up with the concept to develop a fuel cell system monitor with two sensors for simplicity, and also to introduce new methods of signal analysis, and these are, for example, nonlinear response analysis, time series analysis, and utilization of system cause perturbation. The fuel cell system monitoring hardware was developed in collaboration with the Graz University of Technology, focusing on system integration and software development, but also establishing time series analysis, and in addition also considering adaptation of speech recognition algorithms in this application. Now regarding the interface of hydrogen train and hydrogen infrastructure, as I mentioned, a refueling protocol was developed and optimized by considering an optional pre-cooling. So this protocol is now in place, while currently there are no standards for hydrogen trains. And this protocol can be used now further for the industry to support them in this technology. Now I would like to show you in more detail how this protocol was developed. So first of all, I want to mention that for the pressure losses and refueling time, several parameters were specified in the beginning, such as pressure or the temperature. And here you can see in the left that, for example, the positioning of the nozzles in the train was investigated regarding the pressure losses. And regarding the nozzles and receptacles, for example, two types of nozzles were studied, one TK25 and one TK16 high flow. And there was a comparison study between these two by considering the organizational time limit of the train use case that we have. So here in the graph on the right side, you can see that we have 35 minutes of time limit for refueling and reaching the 100% state of the charge because of the train use case at our disposition. So now if we use a TK25 nozzle, you can see that we can significantly reducing the refueling time. And interestingly, this behavior is similar to the behavior of two TK16 high flow nozzles, which additionally compensate also higher differences in pressure. So now this protocol developed and optimized is at our disposition, ready for use in industry, since it's going to reduce also a lot the cost related to the infrastructure. So all in all, everything progressed quite well in the WIVA P&G HyTrain project until now. In addition to the other studies which are still in progress, we saw that the concept for the hydrogen refueling station is developed. the refueling protocols are available for use. Regarding the energy storage and powertrain system, so the basic operation strategy was developed, and currently optimizations regarding lifetime and energy consumption are also in place. Also, some words regarding dissemination, communication, and exploitation. Until now, we had 15 workshops, more than 30 citations, and the number of visits on the project website is still increasing. And we will be handling the project website also beyond the project completion. So all in all, one can say that everything is in place for this hydrogen technology to be introduced to the hydrogen trains and operators in a knowledge-based and minimized and risked way. So Ernst Fleischhacker already showed you an insight to the bigger picture. What I would like to focus on is the impact of HyTrain on the European projects that we are currently working on within FEN Research in European Consortium. As an example, in the Most Hydrogen project, where we are investigating novel technologies for the hydrogen storage, we are really using the comprehensive data from HyTrain for the detailed data input, which would not have been possible without HyTrain. Also, many developments in HyTrain are now basis for the difficult build-up of the green hydrogen economy at the regional level, which started with the development of the hydrogen highway in 2014 in the frame of the Tyrol 2050 energy autonomous strategy, where rollout of hydrogen cars along the Green Brenner corridor took place, and the concept for that was developed by FEN Systems for Hyundai Austria. So this project led to the next project, hydrogen or green hydrogen for Emprise, Tyrol, and Europe, which initiated in 2016, which is actually now itself an established green hydrogen economy. So this project is now providing green hydrogen, the first green hydrogen now to Austria and to the Central Europe. Now the third project, the Zillach-Taliban 2020 Plus Energy Autonomous with Hydrogen. As many of you may know, the concept now has changed. Now the focus is on power on demand process and electrification, which is still in line with the Tyrolean strategy. But of course, now for the implementation of the regional green hydrogen economy, the most important project and even the most cost-efficient project is missing, with consequences which are not yet revealed. But anyway, we simply carry on. The fourth project of the region is the TVAG project, Power to X Kufstein. So this project also faced some delays, and we are hoping that these are now finishing soon, these delays, since this project, as the last project, is actually very important for the redundancy of the existing hydrogen technology and economy in the region. Currently, with our partners, we are focusing on gathering all achievements in buses, trucks, and hydrogen infrastructure in an overarching hydrogen valley project from Trentino in South Tyrol to Bavaria under the working title H2 Brenner Valley. So if you are interested in joining in this next step, feel free to contact us. Thank you for your attention.